So we talked about inverses, and we've said not every function has an inverse. What has to be true for there to be an inverse? It has to be 1-to-1, because that means y doesn't repeat. If it's not 1-to-1, then when you do the inverse, it wouldn't be a function, and so that's the downside there. We talked about how inverses are really just opposites, so you're reversing your x and y values. And we looked at what that did on a graph, how it flipped it over the line y equals x. Today we're actually going to find the equation for an inverse. So this is a 4-step process. First thing, if your original problem is written in function notation, you have to replace that f of x with a y. Then inverses flip x and y. So we will reverse our x and y values. So every x becomes a y, your y becomes an x. Then we have to turn it back into function form. So we'll solve for y, and then notation, we replace that y with an f inverse of x. Remember, this was a notes handout. You should have a package for that. So change f of x to y, switch x and y, solve for y, and then at the very end, instead of y, we write f to the -1, that f inverse of x. So Friday, I think we did this problem where I had you graph the inverse of that function. Let's actually find the inverse. Or maybe it wasn't this exact function. So first step, instead of f of x, we write y. And then inverses switch x and y. So I change my y to an x and my x to a y. Now we have to solve for the y. So we subtract the 3. Okay, and then if I want to solve for y, we would divide by 2. So final answer, we put it back in function notation. We have found the inverse, so the notation for inverse is f inverse of x. The second thing I want is the domain and range of both the function and the inverse. So really 4 things: function, domain and range, inverse, domain and range. But remember, the domain in the original function, the x's in the original become what? The y's in the inverse. And the y is our range. So the domain of the original function is the same as the range of the inverse. So I put little subscripts. You can't just say d equals r, but if I said the domain of the original function is the same as the range of the inverse. Or you could list all 4 out separately. All right, so if we look at the original function, remember when we were talking about domains, we're looking for things that do not exist. So we have that happen if we have fractions. We know the bottom can't be 0. If we have even radicals, we know whatever is under the radical has to be greater than or equal to 0. Do we have any concerns here? No, it's just a line. So my domain is negative infinity, positive. Now the range of my original function. The range of the function will be equal to what? Because the y's in the original become the x's in the range, or in the inverse. So if I look at my inverse, I have a fraction, my denominator is 2. Does that ever equal 0? No, so that one is also. It's harder to look at something and know the range, but we could just jump to the inverse and find domain again. Any questions there? this one. First step is mhm. And then I have two x's, so that means I get two y's. All right, looking at this, where would we begin? Okay, if we want to get rid of that fraction, we could multiply by our denominator. So if we multiply the y minus 1 on both sides, so I get xy minus x equals 2y plus 1. We are trying to solve for y, and I have two different y's. So what we have to do is get those on the same side. Okay, so if I subtract over this 2y, my x doesn't have a y with it, so I want it to go away, so I'm going to add that x over here. So everything with a y on one side and everything without it on the other. Xy minus 2y, are those actually like terms? Can we combine them? No. So what else could we do? Well, if we did that, we would have y minus 2. Factor out the y. They both have it, so if we factor it out. So then, we can divide the x minus 2. So y is 1 plus x over x minus 2. And final step, instead of y, we write, my inverse is 1 plus x over x minus 2. Okay. Then I need domain and range of everything. So the domain of the original function is the same as the range of numbers. Okay, if you look at your original, what could x not be? Can't be a 1, because that makes the denominator 0. Alright, then the range of the function is the same as the domain of the inverse. Harder to look at it and know the range, but if I look at my inverse, what's my domain? Two positive. Any questions on that one? You guys do this one for me. So y equals 4x plus 2 means x equals 4y plus 2. Solve for y. You can have x minus 2 over 4. If you wrote it as 1/4 x minus 1/2, that is also fine. So then our inverse is this. Domain and range. Domain of the original is equal to the range of the inverse. The original, no fractions or square roots, so it is. The range of the function is equal to the domain of the inverse. Looking at the inverse, we have a fraction, but my denominator is just 4, so it is also negative infinity, positive infinity. All good? Okay, let's look at this one. Find the inverse of f of x equals x squared if x is greater than or equal to 0. Why would I say x had to be greater than or equal to 0? What does x squared look like? It's a parabola. Is a parabola 1 to 1? No. So this would not have an inverse to start with. However, if I'm only taking the part greater than 0, that means we're not looking at the other half of the parabola. Does that have an inverse? Yes. Okay, so we can take something that's not 1 to 1, and if we restrict the domain, we might be able to still find the inverse. So x is equal to y squared. Square root, typically with that you would add a plus or minus. However, since I already know x is positive, that means y has to be positive. So y is just the square root of x. Likewise, if x had been a negative number, would we have just been able to add a square root here? Can we do the square root of a negative? No. Right, my domain of the original is the same as the range of the inverse, and I already told you, the domain of the original, we only wanted bracket on 0. Range of the function is the domain of the inverse. Okay, if I look at my inverse, I'm doing the square root. If you have the square root of something, what do you know? It's got to be a positive, so it's x has to be greater than or equal to 0, so 0 to infinity. One more. So y equals x plus 5 over x minus 3. Switch x and y. So now, what do we do? So if I need my y's on one side, we can subtract over this y. Anything without a y needs to go to the other. So it's better, we have all the y's on the left. What would we need to do now? And what would that leave me with? Divide. So our inverse is 5 plus 3x over x minus 4. Domain of the original is the same as the range of the inverse. If I look at the original, what can x not be? So negative infinity
to 3 and 3 to infinity. The range of my function is the same as the domain of the inverse. If I look, range is harder to tell, but if I look at my inverse, what's my domain? Let's actually use sketch graphs on this one. This is kind of going back to the last unit when we were graphing inverse functions. The first one, x can't be 3. What happens at 3? Open circles when it cancels. When the denominator is 0, what does that make on the graph? A vertical asymptote. Remember those dashed lines that we can't cross? If we had an x minus 3 on top, that would cancel out as well. That was a hole. This one would just be a vertical asymptote at 3. The horizontal asymptote, it was 1x over 1x, so what's your horizontal asymptote? 1. Okay, and then if you used your graphing calculator to kind of fill it in, of course we could get more accurate if we wanted to. Your graph is going to look something like this. Okay, this is just a very rough sketch. All I found exactly was my asymptotes. But here's the connection I want to make. When you graph your inverse, where's your vertical asymptote? At 1. Where is your horizontal asymptote? We'd have a 3x over 1x, which is 3. So what happened? They flipped. Okay, and then from there, it's going to be, you can use your graphing calculator if you needed to. It looks like this. So what we're seeing is that because x and y flip, your horizontal and vertical asymptotes flip when you do this. All right. Any questions about that? So, just a couple things testing if we know what inverses mean. F of x is the number of cars that can be built for x dollars. Alright, so in my original problem, if you think about ordered pairs x and y, x was dollars, y was the number of cars. Okay, then I asked you a question about the inverse. I'm telling you in the inverse, the x is 1,000, and you're supposed to tell me what the y means. But you know that in a function in an inverse, when you look at those ordered pairs, what happens to them? They flip. So 1,000 is the number of cars. So the thing we're looking for is, so F inverse of 1,000 is the total cost for 1,000 cars. So that's really just checking if you understand that the x of your inverse was the y in the original. Any questions on that? Final example of the day. Here is a graph. This is of the function. I want to find the following. And notice we have the function, but these are talking about the inverse. So if 2 is the x of the inverse, what was it in the original? Y. So it's asking us essentially to find x when our y is positive 2. So if I look, when my y is positive 2, what's my x? 0. Because this was the point 0, 2, so the y was 2, you're getting the x. So f inverse of 3 means find x when the y is 3. So when y equals 3,
It's either 7 or 8.
so f inverse of 9. So we need our x when the y is 9. Mhm.
It looks like I got a 10 by 10.
So that would be 9. Okay, and the reason we had to flip them is because the graph was for the original, and I'm asking you points about the inverse. Any questions for me? So I am done. You have a Math Excel assignment that I opened Friday, so you have time to work